So today we're gonna go over IR stuff and do Kahoot on IR too. Uh-huh.
Hi,
Hey Alicia, how are you today? Happy Halloween.
I'm doing good. How are you?
I'm doing fine. I'm doing fine. Let's see. Let me join from my iPad. Let's see. How's your guys' Halloween going so far?
Lots of studying.
Lots of studying. Let's see. Okay. Let's see. Okay. So today let's go over a lot of IR problems. Um so what IR tells you is a functional group is present in an unknown molecule. So they might give you the molecule and they might ask you like what wavelengths, like what peaks you might expect for this structure, right? And to do that, you have to identify all the functional groups present in that structure and then have this chart memorized or on your note card on the test where if you have anything 1500 and below, that's called the fingerprint region. So there's no like functional group you have to worry about there. 1600 is the alkene, 1700 is the carbon double bond oxygen, 2100 to 2300 is the triple bond region. So you could either have the alkyne or nitrile, and you could tell that if they give you the chemical formula. If you have a nitrogen present in the chemical formula, then you have a nitrile present. The 3000 base picture is always almost there because we always almost have the we almost always have the sp3 carbon hydrogen, right? An exception would be just a regular benzene ring, right? A regular benzene ring will not have that sp3 carbon hydrogen peak. No sp3 carbon hydrogen base peak, right? Because there's no sp3 carbon at all. All of these carbons are sp2 hybridized. Um, if you see a sharp peak at around 3100, that's going to be an aldehyde. Well, no. An aldehyde is 2700. At 3100 is an sp2 carbon hydrogen. So a benzene will have a sharp peak at around 3100, showing these sp2 carbon hydrogens. And it will also have the alkene carbon double bond carbon peak at 1600. If we see a broad peak at 3300, that's an alcohol or a secondary amine, right? And that one broad peak will show like one hydrogen bond, right? This alcohol here can do one H bond. This secondary amine here can do one H bond. So if we can do one H bond, that's going to be represented by that one big broad peak right there. If you see a fang-like looking structure like this with two peaks, that's going to be a primary amine, meaning that it could do two H bonds, right? Because it could, this nitrogen here, the primary amine, has two hydrogens that it is bonded to. If you see a sharp peak at around 3300, then that shows that you have a terminal alkyne, right? For example, if we have this terminal alkyne right here versus this internal alkyne, both of these alkynes will have a sharp peak at around 2100 to 2300 to represent the C triple bond C, right? But the terminal alkyne will also have a sharp peak at around 3300 to represent the sp carbon hydrogen bond, which is this sp carbon hydrogen bond right there, right? Directly attached to, like that hydrogen directly attached to the sp bond, sp carbon. The internal kind will have no sharp peak around 3300 because it has no sp carbon hydrogen bond. If you look at the sp carbons here of the alkyne, those carbons do not have a bond to hydrogen, which is why they would not have that peak at 3300, that sharp peak at 3300, right? Let's see, there's some more conceptual stuff to this. Like what the wavelength represents, which is like how much let's see, how much D shielded the peak is, but then that's gonna talk more about HNMR. But the best way to do this is just, let's do like more practice problems on this, and then teach you the concepts as we do the practice problems. So, do you guys have any questions about this IR chart so far?
No.
Uh-huh. That's good. Um, do you guys have any problems right now, or do you guys want to like jump straight into the Kahoot and learn more about the IR from the Kahoot? Kahoot? Okay, let's do Kahoot. Kahoot. Okay. Yeah. Ooh, just to make you guys more comfortable with IR, I'm going to teach you guys a little bit more about IR. Oh no, that's 118B. Let's go 118A content review session. I should post this to that website too. Let's see, 118A content review sessions. Let's see, IR, stereochemistry, IR. Yeah. Ooh, okay, okay. Yeah, this is good practice. Okay, I'm just gonna import this to the document we have right now with the key and everything, explain it as we go on, and then we can jump into the Kahoot after I explain this. Right. Okay. So an example problem for like this is from Levin's class. She gave you this IR with the wave numbers here, and she wanted you to label the indicated peaks with the type of bond, like C double bond C, O single bond H, which is an alcohol, SP CH, which is the 3300 sharp peak right there, and then that we talked about earlier. And she wanted us to circle the molecules that would that could be the unknown compound A in the structure here. So do you have yeah, I think Elisa has a screenshot of this. Do you have a screenshot of this? Kathy? Mhm. Yeah. I think yeah, you could take a picture, a screenshot of this right here. Okay. Yeah. So we see A is that broad peak at 3300, which is the OH or NH bond. B is showing the sharp peak at around 3300, so that's the sp carbon hydrogen bond, the terminal alkyne hydrogen. C is the regular sp3 carbon hydrogen peak. D is going to be the triple bond region, so it could be C triple bond C or C triple bond N. I think she would have accepted that as well. E, this is around 1700 right here. This is like 1500 in the middle, in between 1000 and 2000. So this would be 1700 carbonyl. F right here, fingerprint region, right? Anything 1500 and below, we call that the fingerprint region, which shows single bonds to like random things, right? So this structure here is the correct answer because we do have a C triple bond C right here, which is the um, alkyne. Oh yeah, so when you first do this practice right here, um, it's gonna take time for you to like refer back to the chart every single time. Yeah, you're just looking at A. A right here is showing this broad peak, and that broad peak, if you look at the chart right here, is this broad peak in blue that I drew, which represents the alcohol or secondary amine, the NH. Right. It's just like the more practice you do, the more quick you get with it. Right. So, let's see here. What can we do? Okay, so yeah, let's keep going. Let's keep going. This structure is the correct structure because we have the C triple bond C present. We have the SPCH present, the terminal alkyne. We have the carbonyl present, and we have the alcohol present. Right. Other structures here are wrong because they are either missing a functional group or they added like an extra functional group that was not present. Like, like for example, this compound here had an aldehyde, and looking at that chart, where would you guys expect the aldehyde peak to be at in the IR graph from this structure? 2700. Yeah, around 2700. Um, right? If we are here, 2700 would be something somewhere around here, right? There's nothing there, right? So if there's nothing there, there's no aldehyde present. And if there's no aldehyde present, that would make this structure incorrect. Yeah, then that's how you would like do all this practice. But I don't know how Wei and Farhat will test these kind of problems. We'll see if when you guys send me the problems. But this is like Leibniz type problems here. Like list what bonds are present in that range. The signals for single bonds, fingerprint region. This one's Leibniz test. So if we match an unknown compound's IR to the IR of an exact structure of another compound that we know, and it exactly matches, like everything matches the single bonds and the functional groups, then we could say we could tell what the unknown compound is, which is the known group that we have. This is just like carbonyl bond around 1700, which is this range right here. It's not this answer because that's too low to be the carbon double bond oxygen carbonyl, right? So this is more like way like questions, like Elisa showed last night when we were going over like what would you not expect, or like or something like this, like which they give you ranges of wavelengths, and then you have to know like which wavelength is too low for carbonyl. C double bond O is around 1700, which there too low, and this one here is very close, but it is still great. So the cardinal, there's a lot of them that we talked about: aldehyde, ester, amide, ketone, isohalide, carboxylic acid. They will be around 1700, but they will still be variable, right? So ester could be like 1710, carboxylic acid could be like 1750, ketone could be like 1730, right? They are variable. They will change depending on what carbonyl it is. They would not be the same, but they will still all be around the 1700 range, right? So it's like a ballpark range. The OH single bond, which is that like OH broad peak at around 3300, is going to be at 3000 to 3600. OH single bond has a broad shape, so some peaks will have a sharp peak, some peaks will have a broad shape, like the OH alcohol bond. Alkyne sp carbon hydrogen is going to be around 3300. This is this would be too high, too low, too low, too low. Sharp peak, alkyne. Yep, yep, yep. This is the same kind of problem here. I can send you guys this document, like a blank copy of it, and then have you guys practice on your own time. But here are some like tips and tricks of interpreting IR spectrum. If you see 2100 to 2300, think of the triple bond region. Yeah, I'll send it to you guys through Discord after the session for you guys to practice on your own. And then you guys have questions, you can ask me through Discord or in office hours. I could explain it more clearly in office hours. The triple bond region, 2100 to 2300, could be either an alkyne or nitrile, right? But this alkyne right here, you could have two kinds of alkynes. You can have a terminal alkyne or you can have an internal alkyne. The terminal alkyne will have this sp carbon hydrogen peak at around 3300, and it's a sharp peak. But this internal alkyne here will have no sp carbon hydrogen bond, no sharp peak at around 3300, right? So that's how you tell the difference between if you have a terminal alkyne versus if you have an internal alkyne in the structure. Discussion. said that double bond. Uh, wait, TA said that double bond is 2000 to 2500. Like what kind of double bond? C double bond C or C double bond O, or what kind of double bond? Alkene, carbonyl, or is he talking about some other double bond? C double bond O. C double bond O would be around 1700, not 2000 to 2500. That's too high. So C double bond O and C double bond C are going to be different. They're very close to each other, but they're different. C double bond O is going to be higher. It's going to be around 1700, and then C double bond C is going to be lower, 1600. Right? Wait, I mean 1500 to 2000 for double bond. Yeah, so that still falls in the range 1500 to 2000. That's still in the double bond region. Yeah, and 2000 to 2500 triple bond. Yeah, triple bond, double bond. Yeah, that still falls into this graph as well, but this one is just a little bit more narrow. Yeah. Uh-huh. All right. Okay. So if you have a carboxylic acid peak at 3300, which is the peak that merges with the sp3 carbon hydrogen base peak, and an aldehyde at 2700, those peaks will always pair up with a carbonyl peak at around 1700, right? Because if you look at the structure of a carboxylic acid and an aldehyde, these structures here have a carbon double bond oxygen, carbonyl, right there, right? So they will always pair up with each other. An sp2ch peak at around 3100 will always have the C double bond C peak at around 1600, right? Because if we have this alkene right here and we have this sp2 CH bond, that will always pair up with this C double bond C peak at 1600. But a C double bond C peak at 1600 will not always have that sp2 carbon hydrogen bond at 3100, right? An example would be this right here, where this is a tetra substituted alkene, right? Meaning that this alkene here has no bonds to hydrogen at all. If you look at the sp2 carbons of the alkene right there, these carbons have no bonds to hydrogen. So that's why this alkene specifically would not have this peak right here, the sharp peak at 3100 to show the sp2 carbon hydrogen. So here are like some like tips that I came up with that a lot of people like got confused with, and how to interpret them and guess the unknown molecule more accurately, right? And this right here just came with a lot of practice. As I like did a lot of practice, I noticed these patterns. But I need to get more data, more practice for these new professors that are teaching 118, like Wei and Ferhat, and then I could come up with more tips and tricks for you guys, depending and based on their practice, right? But are you guys ready to try some Kahoot problems? I kind of went too fast on this, um, but I think it would make more sense as we do the Kahoot like last time. So let's just jump straight into the Kahoot, and then after the Kahoot, I'll help Wiley with her midterm this tomorrow, right, for 128. Yeah. Okay. Let's see. I are 15 questions. That's good. Okay. Host live game. Okay. Let's do Halloween mode. Happy Halloween. Let's see. Let's start. And Wiley, did you also for IR yet for your class 128A? Yeah, okay, yeah. So you could join this Kahoot too to get extra practice, and if it's included in your midterm tomorrow. Oh, you didn't learn IR yet? Oh shoot, you have no idea about spec. Oh shoot. You could just join anyway, just for funsies. Leisha, Catchy, H. Yeah, you change your icons. Yeah, just for funsies. Gosh, Alicia, Elia is what is that? Bunny. Kathy is a brain. Wiley is Frankenstein. Earth. Okay, let's go. Oh yeah, have that chart in hand. That chart that I showed you guys earlier. What types of bonds are found around 3300 in the IR spectrum? Yes, so the types of bond that are found around 3300 are the alcohol, like broad peak, the carboxylic acid, the amines, like secondary primary amines, the sharp sp carbon hydrogen peak, the terminal alkyne hydrogen. Right? If you look at the red option, where would that show up as? Like if we look at the SPCC and SPCN bond, the triple bond region, where's this triple bond region? Oh shoot. 2000 to 200, this chart right here, 2100, 300 right here. Of this really quick, because this will be like much needed for this Kahoot. Uh, uh-huh. Let me know if you had to have the screenshot ready. Okay, you got it. Okay, let's go back. Okay. Okay. True or IR can tell us the exact structure of an unknown compound only by matching a known compound. So if you match an unknown compound's IR to another known like compounds IR, if they exactly match. Can you tell what the unknown one is? Yeah, so for this one, it is true because if we like exactly match the like the IR, like the sharp peaks, the broad peaks, the fingerprint region as well, the jagged peaks, and everything matches, then that unknown IR compound is our known compound, right? So we know that unknown compound. Yeah, the fingerprint region is if you look at the chart, the region at 1500 and below, that dashed line, right? That dashed line would just show single bonds between like carbon and carbon, single bonds between carbon and oxygen. We ignore that when we interpret IR, right? It's not important. Like the more important ones are the ones that I showed you guys on that chart. Yeah. Mm-hmm. So if let's say you have an unknown compound, you have no idea what it is, and then you have another compound, but you know what that compound is, and you know what IR is for that known compound. If you put that unknown compound to the IR, and then that IR is exactly the same IR as the known compound that you know, then that unknown compound is going to be that known compound. Right? Did that make sense? Yeah, you have to memorize those numbers if you don't have a note card. Right? Way allows a note card. I think Levens also allows a note card. So if you put that chart in your note card, you don't have to memorize it. But it's best if you do because these IR questions will come up again in a 128B and C, and also 118B and C. Yeah, so you guys get a note card. these numbers. Oh, that's good. Yeah, so this one right here is showing you guys the fingerprint region, right? Between 500 and 1500. And the fingerprint region is showing single bonds. So that was a good question that Wiley asked. Or like before this question, like what is the fingerprint region? Um, that's the region where you could ignore, but that's gonna show single bonds between like random atoms, single bonds between carbon and carbon, single bond between carbon and oxygen, single bond between carbon and nitrogen. But that's like you could think of it as single bond region, fingerprint region. Like we ignore that. Yeah, that's the fingerprint region that shows single bonds. Okay. Oh, nice. That was a quick one. Yeah, fingerprint region, not the harmonic, vibrational, or unicorn region. Be careful of this one. There is one that's very close, but not exactly. Nice, nice. The one that was very close is the TO one. That's too low. The CW1O would be around 1700. Uh, so without the note card, just keep drawing out the IR chart, like the one I drew out, like and you screenshotted. Keep just draw that out and keep like doing it. Look at the card, and then try the next time you do it. Try not to look at the card, and then like memorize one thing at a time. Like start from the fingerprint region, and then the very next thing after the fingerprint region is the C double bond C, right? That sharp peak. And then the one after that is 1700, the C double bond O. And the one after that is the triple bond region, 2100 to 2300. And then the one after that is going to be aldehyde. The one after that is the 3000 sp3 carbon hydrogen peak. And after that, there's the crazy like circus going on there. Alcohol, 3300 brought peak. Or secondary mean, double fang looking structure, primary mean, NH2. You see that a big broad that merges with the sp3 carbon hydrogen, carboxylic acid. Sharp peak at 3100, sp2 carbon hydrogen. Sharp peak at around 3300, terminal alkyne. So just like keep writing it down and down and down and down until you could get that memorized. Right. like I had leave-ins for 118A, so I didn't have to get it memorized. I also put it down on my note card. I had Nasiri for B and C, so I had no note card for B and C. But yeah, that's how how I would do it. I would just keep writing it, explain to myself, and refer back to the notes if I need to, and then the next time I do it, I would like try to remember the next one. Yeah. Nice. They're different. They're very close, but they're different. The carbonyl C double bond O is 1700. The alkene C double bond C is 1600. Nice. Yeah, and these questions here are like directly off of Levin's actual quizzes and exams. So they may be similar to your guys' professors as well. Or this would definitely be very similar to for Wiley's class because you have leave-ins for 128A. Nice, nice. But when you get to IR. Mm-hmm. Nice, nice. Sharp peak, sharp peak. Yep. Mm-hmm. Nice, nice. Um, peak A, that broad peak at around 3300 shows an alcohol or secondary amine, OH or NH bond. Yep. Mm-hmm. Yeah. So that's a sharp peak at around 3300, showing the SPCH bond, the terminal alkyne hydrogen bond. Nice. Mm-hmm. Oh my gosh, you guys are getting the hang of this. That's good. That's good. What? Oh my goodness. That's like 1 second right there. Yes, yes. You guys are catching the pattern. It's going A, B, C, D, E, F. That's good. That's good. OCHM is all about pattern recognition. Oh, you guys got it wrong. Oh, okay, okay, okay. Oops, oops, oops. Okay, okay. So let me explain this. I thought you guys all got it correct. Let me go back. Let me go back. Okay, okay. So they're asking for peak E, right? And peak E is a little bit above 2000. So let's say that's like 2100, 2200. That's the triple bond region, right? Which is the CC or CN, triple bond, alkyne or nitrile. The aldehyde H, where would that be? Where would that be shown at in the IR? Around what range? 2700. Yeah, if you look at that chart, it's gonna be 2700-ish. So that was a little bit tricky because you saw the chart peak right next to the like, well, not right next, but then like next to the base peak. But it's not 2700, right? Because if you see the 2000 number and 3000 number, in the middle of that, like that line right there, is 2500, right? And that sharp peak is below that 2500. So it's not 2700. It's gonna be in between 2000 and 2500, the triple bond region. Yeah. So read the scale and be careful of the scale as well of the IR. This one I hand drew out, but the IR you get would be like more clear with um like a different kind of scale. Right. Uh-huh. Okay. Yes, nice, nice. Double bond C 1600. It's not C double bond O 1700 because in the middle between 1500 and 2000 is 1750. And if it was a carbonyl, then the sharp peak would be closer to that midline between 1500 and 2000, right? But it's closer to the 1500, which shows it's around 1600, or the alkene C double bond C. Nice, nice. So now you're gonna bring in all of the information you gathered and try predicting what the unknown compound could be. Right? Make sure every single functional group that we found earlier matches with the compound. Yeah, this was a question from Levin's quiz or midterm. This type of question for IR. Or 118A. She might change it up for 128A, but just send me it and then I'll see if it's similar. Okay. How are you feeling about your midterm tomorrow? Okay, yeah, so let's analyze this problem. Right, yeah, 20-minute quizzes is really fast, and Levin's is like known for having like no time like at all for like the quizzes and exams. A lot of people leave it blank. The vocab is annoying too. Yeah. Right. Okay, so I'm gonna type out the functional groups that we found. A is alcohol. B is sp carbon hydrogen terminal alkyne. C is the sp2 carbon hydrogen. Okay. Alkene. D is the regular sp3ch. Right. And then E is the CC or CN triple bond. And then F is going to be C alkene double bond. Right. Okay. So now if we look at okay, so let's do the ones that you guys chose. Dark blue, right? Dark blue has a carbonyl, carbon double bond oxygen. But we said in the IR here, there's no 1700 peak, so that's why dark blue is incorrect. There's no carbonyl peak. If we look at gray, right, we do have the terminal alkyne, but we don't have the aldehyde peak, right? The gray or pentagon option has an aldehyde present, but what would the aldehyde be shown at on the IR? It's 2700-ish, yeah. 2700-ish, but we don't have that peak at 2700. Okay, so that's why gray is incorrect. And also it's missing the alkene peak. We have an alkene present in the molecule as well. So brown here is correct because it has everything we found. It has the alcohol, it has the alkene, it has the terminal alkyne, right? So that's why brown is the correct answer. Nice. Hey, Xinyan.
Hi.
Any questions on this IR problem? Do you remember doing this IR problem? It's in like I don't know if you were there for my 118 econ review, but do you remember doing this Kahoot?
Yeah.
Yeah, they're learning IR right now, 118 and 128A.
Oh, okay.
Yeah, yeah. Let's see. Okay, that's good. Okay, nice. Is IR making more sense now after the Kahoot? Yeah, that's good. Yeah. Okay. So what we could do now is yeah, send me the lecture schedule for 128A and also send me did she send the practice midterm for tomorrow? At the end of the session, we could also do another IR practice. But we'll see. Or unless just, let's see, I don't know. Yeah. Let me show Zinian this really quick. Chapter 22 stuff that you need to know for this 118C midterm. But okay, boom, copy, paste. There you go. Okay, let me get rid of this. Yeah, you could send me files through this email here. Yeah. Or if you have Discord, you could add me on Discord as well if it's easier to send files. I think that's my name in my numbers. Oh no, wait, it changed. Discord changed. I forgot the phone number. It's just that. Okay. Okay. Yeah, so Zinyan, here's chapter 22 topics. In excluding the nomenclature and some trivial questions that Fair Hat includes, like some weird uh older facts or medicine, drugs. And like this is not including nomenclature, but it's including the reactions, mechanisms, and acid-based stuff too. Right. So I can zoom out for you so you can see the whole chapter 22 topics for Fair Hat. Okay. Yeah. Do you guys want to do more IR practice for today? Um or yeah, I have more. But Zanin, did you have a question to go over or any specific practice problems?
Oh, no. I was just gonna check if you were talking about any topics in like
118C?
yeah.
I see. Okay. What the heck? Someone just sent me a friend request on Discord flat. Let's see, what is this person saying? Are you flat, Wiley? Or oh, I see. Okay. Okay. That's good. Let me accept friend request. 128A. Let's see here. 128 syllabus. Okay. Quiz 1, organic structure. How did your quiz 1 and quiz 2 go? Did you have time to finish the quizzes? Okay, that's good. That's good. That's good. Uh-huh. Let's see. Okay, let me pull up a blank copy of this so that we could do practice on this. Let's see. Send a copy. Okay, and to this. Open. Yep. Okay. Yeah, let's do this here. Boom, boom, boom. Yes. Okay. Zinyan, do you want to try tutoring them on this IR stuff?
Really?
Do you want to try? Or no?
I mean, I can only say like the steps.
The steps? Okay. Yes. You can ask them questions or like, yeah.
Well, did
Uh-huh.
you, are we given the formula?
No, they're not. We're not given the formula. We're just given the IR spectrum.
Oh, really?
And then this question here is asking for what kind of bond would you expect the peak to represent,
Oh, okay.
right? And then some of them get a note card, like Elysia and Wiley, but not Kathy, so she has to memorize those. But here's the IR chart again. Yeah. Okay. Here you go. Okay. What would be A? Actually, that's okay. It's okay. It's okay. So yeah. Yeah. What would be A? Anyone can answer. Uh-huh. Really? Yep. OH or NH. That's correct. Nice. Okay. What would be B? sp3CH. Correct. The boring carbon hydrogen bond, single bond. That's almost always there for all structures. What would be C? Be careful of the scale, right? Look at the scale. The wavelength, wave numbers, x axis. Alkyne or nitrile, yes, right? Because in the middle between 2000 and 3000 is 2500. And like your TA said, Kathy, that region, 2000 to 2500, is the triple bond region, right? So that's going to be the C triple bond C or C triple bond N. Nice. What would be D? Carbonyl. Carbonyl. That's right. Carbonyl, right? Because that's very close to 2000. So that's going to be 1700. This is 1500 right here in the middle, in between. So that would be C double bond O. Okay. What is the name of the region E? That's 1500 and below. Fingerprint region. Yes. E is fingerprint region. Fingerprint region. Okay. Now we have all of the information that we can get from the IR, which shows us the functional groups present in the structure. Now for the next problem here, I want you guys to use the information that we found and find possible and plausible structures based on the information. Would there be a type of question where you have to construct the molecule or its formula from scratch based on its IR? No, you will not get a question on that because there's no way to know like how many atoms you have on the IR, right? The IR, what it's good for is to tell you what functional groups are present on the compound. But when you get into HNMR, which is a more advanced, more specific spectroscopy technique, you can know exactly how many hydrogens are there and exactly where those hydrogens are on the molecule. Like if it's on the tertiary carbon, secondary carbon, how many neighbors it has. We'll go over all those when we go over HNMR. But HNMR is a very powerful tool. because HNMR will allow you to predict the exact structure of an unknown compound, right? IR is a weaker tool, weaker method because it doesn't show you the exact molecule. It just shows you what functional groups are present in the unknown compound, right? But HNMR will tell you exactly like what the bonds are, and they'll give you the chemical formula for that as well. You need the chemical formula for that. Mm-hmm. C. Okay. Kathy said C and I. C and I, right? And let's make sure that's correct. C has the carbonyl, that's good. The alcohol, that's good. The triple bond, C double triple bond C, and we know it's an internal alkyne, not a terminal alkyne, because if we had a terminal alkyne, what other peak would have to be present in RRR if we had a terminal alkyne? Yeah, H, SPCH, right, bond, and where would that show up at in the IR? At the SPCH bond, where would that show up as? Where and what would it look like, sharp or broad? Yeah, around 3200, 3300-ish, sharp peak. Yes, sharp peak at around 3200, 3300. Nice. But we didn't have that peak, right? We didn't have this sharp peak at 3200, 3300, so we don't have a terminal alkyne. So we have this alkyne here. That's good. Cross that out. We have the sp3 carbon hydrogen. Cross that out. Cross that out. Okay, that's good. So C is good. I and H is one of them, which is this one. That's good. Internal alkyne, good. C double one O, good. And then yep, the regular boring sp3ch, good. Fingerprint region, ignore. Right. Everything else is bad because we have no alkene, so we cross that out, cross that out, cross this out, cross that out, because we have no alkene, right? So this is a lot of process of elimination here. This one here does not have an OH or NH, right? So we could cross that out. This one here has an aldehyde, but we do not have an aldehyde, right? Because we don't have a peak around 2700, so we could cross those out. Now, you guys tell me what's wrong with this answer here. Why is this not the correct answer? Mm-hmm. Mm-hmm. Yep. Yep. So there's two possible reasons, and then you guys said different answers, but they're both correct. One of you guys said there's no OH or NH bond, which is required because we have that in the IR. So that's not correct. And also, there's a terminal alkyne present in the structure. But this SP CH bond is not present in the IR. So that's not there as well. So it's missing the OH or NH, and it has a terminal alkyne, which we don't have in the IR. Nice. Nice job. Nice job. Yeah. Okay. So Wiley, when you learn about IR stuff, you have a head start now because this is like all like leave-ins type questions. Do you guys want access to my 118A content review notes and the keys to them so you guys can like use this to practice more? It has all the 118A like notes that I did with practice when I did the content review sessions for AETC in winter of 2023. Yeah. No problem. Okay. You guys can direct message me, private DM me on Zoom, your emails, and then I will send you guys access to um the content review notes for extra practice and notes. Okay. Okay. Leave-ins, Chem 118A, content review sessions, winter 2024. No, winter 2024, not 2023. Um, share. ucdavis.edu. Okay, turn. This one. This is you. Okay. Share. Okay. Okay. Just shared with you guys the folder. Let's see. Oh yeah. And Wiley, you could also like I got your syllabus. Did you have did Levens post a practice midterm? Like practice quizzes? Practice quizzes for tomorrow? It's only one per quiz, one practice. I see. And were you able to finish that practice? Did you have any questions on that? Any questions on the practice quiz that she posted? Okay, you could finish them. That's good. That's good. What you could do is you could send me oh shit, no, but it's tomorrow, and this is my last office hours before the quiz. But for the next quiz, right? You could send me the quiz, and then I could create similar practice problems to the quiz that Levens gave you, and I'll send you a different PDF of the key for extra practice. Yeah, okay. And then we could go over them in office hours as well. Yeah. Just DM me on Discord, like the resources, and then I'll create similar practice problems for you. Yeah. Okay, Ellie's here. Okay. Yeah, so let me Elysia sent that. So let me go save this picture, answer this question. Save image, share screen. Yeah, and that's also where you could send me resources, images, practice problems to go over during office hours. Yeah, no problem. Okay. 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 So, Elysia's question is, which bonds in this molecule will have resonance frequencies in the functional group region? Oh, is this an IR problem question here? If this was asking for IR, like functional groups present in this molecule, the first thing I would do is identify my interesting functional groups, right? Ignore the boring sp3 carbon hydrogen. What two functional groups do you guys see present in this molecule here? An amine, the NH2 right here, that's one of them. There's one more. There's one more here. There's one more functional group. An alkene. Yes, right here. So now on the IR, where would you expect, let's say, this amine, primary amine, NH2, to show up at as? Like what range? Around what range? Zinyan, did you have the IR chart memorized yet, or do you still have to look at the graph?
I have it memorized.
Oh, you have it memorized?
Yeah.
That's good because Kathy she can't use the note card for this quiz, and then she was like, "How do you memorize all this? Do you have any tips for her to memorize it?"
I mean, I don't have a note card. I didn't have a note card for
Uh-huh.
B and C, Moscow and
Yeah, so
Farhad. Yeah.
I
So
know, so
like,
you had to memorize it.
but like I memorized it in like with Lievens because you don't have space for the IR in the final note, like for your final. And like with a lot of practice, you just have it like
Yeah.
in your brain. Just do a lot of practice. And it's like
Right, right. A lot of practice. Yeah.
yeah. And I think it's okay. It's like easy to
Right.
just
And then you
remember
just
like C double bond and
mhm,
carbonyl and nitrile. I think those three are like the major ones. I don't think
mhm,
like the others will like come out a lot.
yeah. Right, right. Just a lot of practice, Kathy. A lot of practice. And as you do practice, you'll see like you're gonna have to use the chart a lot at the beginning, but then when you do a lot more practice, you're gonna see that you don't have to go back to the card anymore or the chart anymore. Right. And I think Levin's or the discussion manual has a lot of IR practice to do. Right. Yeah. So Kathy said there's a 3100 sharp peak around 3100, but that shows the sp2 CH bond. Right. What uh range is the C double bond C, C double bond C in the IR. 1600, around 1600. Nice. What about the primary amine? Yeah, around 3300. Right. And if they wanted to describe like the shape of it, the sp2ch is going to be a sharp peak. C double bond C is going to be a sharp peak. And then the primary amine is going to be this fang looking structure. Right, around 3300. Right, like that. Okay. And that should be your the answer to that question, Elysia. Wait, I think which bonds in this molecule will have resonance frequencies? Resonance frequencies, I think of that as like wavelength, wave number in the IR in the functional group region. Functional group region. So I think it's asking for the functional groups present in that molecule. Yeah. So the only rounded peak is NH2, OH, and NH, or broad peak. Um, Another broad peak would be carboxylic acid, but that carboxylic acid goes crazy. It goes like at 3300 and it merges with the 3000 peak. Right, that's the carboxylic acid. And you're going to see that in 118C, the beginning of 118C. Right, you're going to learn about carboxylic acids in 118C. Yes. What I mean by that is like you learn about the reactions of carboxylic acids in 118C, but you will see carboxylic acids in the IR for 118A, like the structure of carboxylic acids in 118A. Yeah. Uh-huh. Okay, that's good. I hope today was helpful for you guys. Happy Halloween. And yeah, are you guys planning to study more or what are you guys planning to do now?
I have 2 lab reports due tomorrow.
2 lab reports for
Yeah.
118C?
Yeah, I don't know why.
Oh, shoot. Wait, did I share you my 118C lab?
No.
Oh, wait, let
Could
me share
I
it to you.
could I get access? Yeah.
Yeah. Send me your email.
Okay.
Uh-huh. Study more, Elysia? Oh, shoot. For OChem or what other class are you going to study for? Let's see. OChem, then math. I see. Okay. 17B, 17B. Okay. Let's see. Okay. What I can see. Where's my grade scope? Right here. One can see grade scope, share. Let's see right here. Okay. And share. Yeah. Quick clarification. What's the floor? So we had alkene and H, CHSP2, and CHSP3. Yes, all of those are going to be present, but the functional group would be the first three. The last one, sp3ch, they might not consider that as a functional group Yeah, that's the boring one. That's the one that is almost always there. Right, the sp3ch. Yeah. That's it. Yeah, no problem. Okay. I will see you guys next week in office hours if you guys show up. Yeah. See you guys. Bye.
Thank you. Have a good Halloween.
Halloween. Happy Halloween. Good night. Good night. Mhm.
I had a quick question.
Mhm.
Like, do they have a quiz next week?
For 128A, Wiley, the person that was here, I before I didn't know who that person was. I assumed it was a she, but I think that person is actually he.
Okay.
He has a quiz tomorrow with Levens for 128A.
Yeah.
And then Kathy had a quiz with Farhat today. Elysia had a quiz with Wei like on Tuesday or Wednesday.
Oh, okay. So like
Yeah.
next week, you're like less busy, kind
Oh
of.
shoot. Yeah. Next week I could focus more on 118C stuff. 118C stuff.
Okay,
Yeah.
okay. Then I will come
Uh-huh.
out next week.
Yeah.
Yeah.
Uh-huh.
Thank you so
How'd you
much.
do on the midterms, Yin?
Well, uh, good compared to the mean, but I
Uh-huh.
don't think that's really good.
I see. Yeah, you want to improve for the next one. Next one, you know. Did you do all the practice that he posted? Like the practice problems,
Yeah, I
homework?
noticed. Like he had like half of the exam
Uh-huh.
that was like the same from the practice problems.
Yeah, so prioritize that. Study that a lot for
I
the next
got
one. Like,
nearly all of the multiple choice. I just like lost nearly all of the points from free response.
oh, the free response?
Yeah,
Oh shoot. Yeah, I see.
because there was like NH2 that was double bonded to the benzene, and I like wrote H2 PDC to reduce it, but that wasn't right. Because I forgot the double bound.
Oh, the alkene, right? The alkene was
Yeah,
there.
yeah, yeah.
HPC would also reduce that alkene. Yeah, that
Yeah.
was a 118B thing. Like that's tricky. That's tricky.
Yeah, I know. I like didn't see the double bound and like
Yeah.
I just lost all the point. And I couldn't even like guess the thing for the bacteria.
Oh yeah, the penicillin something
No,
penicillin.
no, that's like
Uh,
too difficult.
that's a trivial thing. That's like more biology than OChem.
Yeah, yeah. I don't know why he brought that up.
Yeah, did he mention it in lecture?
I think so, but like I
You
didn't
don't
pay
go.
much attention to like the pharmaceutical stuff because
Uh-huh.
I didn't expect it.
Right. But now you know. So know
Yeah,
like
yeah.
trivial facts, and you might want to put that on your note card just in case, or memorize it before
We don't
the.
have a no car.
Oh yeah, I forgot Farhat.
Yeah. That's like the problem.
Yeah. It gets better though. Like the beginning of 118C is the hardest in my opinion. Like the not amino acids, carboxylic acids, is the
Yeah.
hardest.
But like we don't have a lot of opportunities. We only have a midterm two and we get a final.
I
So
know. Yeah.
yeah.
Right.
Well, and he didn't even post the mean or like anything
Oh
yet.
shit.
Well, he just
Oh, the
posted the
mean?
mean. He didn't post
Yeah,
it like the
59.
highest score or the lowest score or like the standard deviation,
Oh,
anything.
right.
Yeah,
Dang.
nothing.
Nothing. Oh my gosh.
Yeah. So I don't know if
Crazy.
we are gonna get any like a curve or is it, I don't know.
Yeah, I think it will be a curved because if the mean is 59, like everyone would fail. Like if you
Yeah, but like we don't know
curve,
how much he's gonna curve. Is he gonna curve like the mean to a 70?
oh, yeah, if he does a basketball curve.
Yeah, I don't
Mhm.
know. Well, I hope he curves. Yeah.
Yeah, a big curve, big curve.
Yeah. Well,
Yeah.
thank you so much.
Yeah.
Yeah, I will see you next week if I can.
Yeah, see you next week, Xinyan. Bye.
Yeah. Bye.